Okay, so this is a key to worksheet 3.3 part 1, and this is where you're using the properties of logarithms, the multiplication property, the quotient property, and then the power rule, the power property. So in 1a, or in number 1 rather, you have the log, in 1, you have the log base 6 of 3 times 4. And so I'm going to use the product property. So remember, the product property says that when you have the log of a product with whatever base, as long as the base is positive and it's not equal to 1, then that's the log of m plus the log of n. So that was the property you learned. Okay, so that's the product property for logarithms. All right, so then this becomes the log of 6, the log base 6 rather, of 3, plus the log base 6 of 4. All right, so that will be the answer there. You cannot simplify those two. Remember, you want to simplify if you can without using a calculator. You can't figure out what this is. 6 to what power is 3? There's no whole number that's going to equal 3. Okay, 2. So this is log base 6 of 3 plus log base 6 of 4. All right, in 2, you have log base 8 of 8 times x. So again, you're going to use the product property. So this becomes the log base 8 of 8 plus the log base 8 of x. Now this is where you have to use this part. Where possible, calculate log expressions without using a calculator. So you're supposed to recognize, hey, I can simplify this because I know that the exponent here, remember the log is an exponent, so I know that log of 8 base 8 or log base 8 of 8, so 8 to the first power is 8. All right, so I know that this is a 1 right here. So I get 1 plus the log base 8 of x. So that's your answer there. So 1 plus the log base 8 of x. Okay, number 3, you have log of 10,000 x. Log of 10,000 x. So again, I'm going to use the product property. So that becomes the log of 10,000 plus the log of x. Now remember, when you have no base, it's understood to be a 10. So remember, this is a common logarithm. Base 10 is a common logarithm. So here I'm dealing with a common logarithm. So remember, there's no base, it's understood to be 10. So I can figure out what the log of 10,000 is. So I can figure this out because this becomes 10 to some exponent equals 10,000. Well, 10 to the 4th power, 10 to the 4th power equals 10,000. So that's a 4 here. So this becomes 4. So that's 4 plus the log of x. So that's your answer for number 3. So number 3 is 4 plus the log of x. All right, number 4, you have the log base 3 of 5/7. All right, so now this time you're dealing with a quotient. See that fraction, a division? So you're dealing with a quotient. So the quotient property says this. The log base b of some quotient, let's say m divided by n, is going to equal the log of m base b minus the log of n base b. All right, so it becomes a difference. All right, so then this becomes the log base 3 of the numerator, which is 5, sorry, log base 3 of the numerator, minus the log base 3 of the denominator. And you can't simplify this without using a calculator. So this is your answer there. So number 4, you have log base 3 of 5 minus log base 3 of 7. Okay, number 6, number 5 rather, you have log base 6 of 6 divided by x. So again, we're going to use the quotient property. So that becomes log base 6 of 6 minus log base 6 of x. Now I can figure this out just like I figured out what the log of 8 base 8 is. So same thing. 6 to what power is 6? Well, the answer is 1. So this becomes 1. So that's 1 minus log base 6 of x. So remember, log base 6 of 6 is equal to some exponent. So what is this exponent here? Well, 6 to what power is 6. Well, 6 to the first is 6, so that's 1. Okay, number 6, and that becomes, so that's going to be 1 minus log base 6 of x. Okay, number 6, you have log base 3 of 9x. So again, now I'm going to use the product property, and so this becomes log base 3 of 9 plus log base 3 of x. So look at this right here, this. So I have log base 3 of 9, and the question becomes, what is that exponent? What is this exponent equal to? Well, 3 to what exponent is 9? Well, 3 squared is 9. So the log of 9 base 3 is 2. So this becomes 2 plus the log base 3 of x. So that is number 6. So 6 is 2 plus the log base 3 of x. Okay, number 7, you have the log base 2 of y divided by 8. Log base 2 of y divided by 8. Well, again, we're going to use the quotient property now. So it'll be the log base 2 of y minus the log base 2 of 8. Well, I can figure out what this part is right here, log base 2 of 8. So the question becomes, 2 to what exponent is 8? Well, the answer is 3. So this is 3. So this becomes log base 2 of y minus 3. So that's number 7. Number 7 is log base 2 of y minus 3. Okay, number 8, you have the natural log of 2e. Natural log of 2e. Well, again, you use a product. Now remember, natural log has base e. So your base is e here. Okay, so remember, that's a natural logarithm. Common logarithm has base 10. We did that one earlier. So this becomes natural log of 2 plus the natural log of e. Now you see this natural log of e? I want you to remember something. The natural log of e, the ln, that's really log log base e, and your argument here is e. So this right here is this. ln is log with base e. So then again, ask yourself, what is this exponent? Well, e to what power is e? So e to the first power is e, so that's 1. So this right here is 1. So it becomes natural log of 2 plus 1. Natural log of 2 plus 1. So that's number 8. Natural log of 2 plus 1. Okay, number 9, you have the natural log of 3 divided by x. So here you can use a quotient rule. So that's a natural log of 3 minus a natural log of x. And you can't do anything with it without a calculator. So that's number 9. So natural log of 3 minus the natural log of x. Okay, number 10. That's number 10. So number 10, you have the natural log of e divided by y. So again, using the quotient rule, this becomes the natural log of e minus the natural log of y. Well, remember, the natural log of e we just found to be 1, because remember, the natural log of e, this right here that I'm circling, is really the log base e, and my argument is e here. So the question becomes, e to what power is the argument? So e to what power is the argument? Well, e to the first is natural log of e. So I get 1 minus the natural log of y. So that's what this becomes. So number 10, 1 minus the natural log of y. Number 11, you have the log of x to the 4th power. Now remember, this time I'm going to use the power property. Power. All right, so that basically says that you have the log base b of m to the n power. As long as this argument right here is raised to a power, the whole thing is raised to the power, I can take that power and write as a product. So this becomes n times the log base b of m. And so you see this whole thing that's in parentheses being raised to the 4th power, so that means I can take this 4 out in front, and so that becomes 4 log of x. And so there's your answer. So 4 log of x. Number 12, same thing. Number 12, you have the natural log of 6 to the x power. Now, it could have been written as this. Just keep in mind, it could have easily said 6 to the x power like that. All right, just like this right here, you could have said the log of x to the 4th power. All right, so the only thing raised to the fourth power is x. So you take that 4, put it in front. The only thing raised to the sixth power is x. So you take the x, write it as a product. So you can use the power property. So it becomes x natural log of 6, and you cannot simplify the natural log of 6 without using a calculator. So this is x natural log of 6. Okay, so that's the key to worksheet 4.3, part 1.